Today is our last section of the topic for 5, solving rational equations. You've done all of this. I just haven't said you're doing it, basically. Everything we've been doing goes into it. We're going to add in there. We're going to multiply by reciprocals. We're going to reduce, all sorts of fun stuff. Okay, so how do I solve this equation? Set it equal to 0. We don't specifically have to because it's not like squared or above. It's not quadratic or above. But we do need to get x plus 5 out of the denominator, correct?
Yes.
So I would multiply both sides by x plus 5. Question. So I had x plus 5 and x plus 5. And on the left, they would reduce out, wouldn't they? So I have 2 equals
4x plus 1.
4x plus 20. And this is something you guys have dealt with over and over and over with, yes? How about subtract the 20?
Whatever works. What? Why are we subtracting the 20?
Because the 20 is positive.
Moving it over.
You have to zero it out.
Oh, yeah.
You have to do other one day one.
Oh, I was trying to get it to where we were factoring.
But
then
it's
when
first
she
degree. It's first degree, so I don't need to factor.
Oh.
And
Okay.
so divide by 4. So x equals negative 9 halves. And you're going to leave it as a fraction. Now, is negative 9 halves okay?
Yes. Yes.
What can't x be?
Negative 18 or 4. Or it cannot be 2. Or negative 18. 5. Negative 5.
Negative 5.
Oh.
How do I know it cannot be negative 5?
Went back to the original thing and you said x plus 5 into the denominator.
Oh.
So we set it equal to 0.
So you set your denominator equal to 0, right? Now, you are going to need to take a second and decide, stop and look at your answers and see if you get an answer that makes it 0, you have to exclude it from your solution set, or it's no solution if it's all of them. If you have to be aware of that.
So why did you write x plus 5 equals 0?
I was showing them why I knew it was negative 5. Because you set the denominator equal to 0 to find out what it can't be. And the denominator is x plus 5. Yep. So my answer is x equals negative 9 halves, and x cannot equal. But obviously it's not, we don't have a range of things that it equals here, do I? But you always need to be aware when you have a rational expression or a function, what x cannot be. Okay? So now what do I do the next one?
Use
Both sides minus x minus 3.
Both sides
So-
by x minus
Do it.
Well, I was one step ahead of you.
You already did it?
No.
Well, Carol, I was a step ahead of you.
Okay, so you got 1 equals x, 5x minus 15.
Yes.
No,
Then you add 15.
You didn't get that?
no,
Then you add 8.
You add 15,
after
divide by 5.
Yeah.
It'd be 16.
Yeah.
Okay, 15 plus 1.
Oh, I multiplied.
Don't do that.
Anybody else multiply?
No.
No
I
one
know
else?
what-
I'm the only one that made that mistake?
Yes.
Yes.
In the world, probably.
And don't make it again. Vote.
Mic drop.
That's a little mean. Okay, so x equals what?
Ma'am.
I'll remember that kind of astringent when I'm grading tests, right?
No, I didn't say anything.
I
think
think
that's
that's
okay.
okay. I think I
Don't
should
move
talk.
on yet.
Okay.
Literally
That's
just tally.
equal to-
So x is 16 fifths. So is it a good answer?
Yes.
Yes, and it couldn't be
3.
3. Okay, so I can't put 3. And the thing is, where this equals something, I just want you to be aware what it can't be. Does that make sense? Because it's never going to have the opportunity to be 3 because it's equal to 5. But if I would get 3 as an answer, this would be no solution.
Oh, so if
So like when it wasn't equal to 5, we had to say x couldn't be 3 because x could have been anything. But now x, to make this a true statement, since we have an equation, can only be 16/5.
Are all
That's-
problems gonna be like that?
No.
Or
If it was no,
or something is equal to a solid.
it's got a little harder.
Okay. So we basically we need to solve the equation, but on the left-hand side, what do you think I need to do with it before I do anything else?
Factor.
Add 'em.
Add them. I need to add them. Okay. So it's just like our complex rational expressions we had on Friday. We had to reduce the numerator, the denominator, and then multiply by a reciprocal. We just need to make sure both sides are one fraction. So I need to get a common denominator, which would be what?
X minus 5, X minus 3.
Wouldn't it just be x minus 5 and x minus 3?
Yeah.
Because they don't have any common factors?
I mean, they have 15.
No.
Factors.
Factors, not multiples, factors.
Like 1 and 5, 1 and 3.
But x minus 5 is one thing, isn't it?
Yeah.
So this is my factor, and this is my factor. So what do I multiply 1 by?
X minus 3.
X minus 3. I multiply x by
X minus 5.
x minus 5. So I'm going to have, what, x minus 3 plus x squared minus 5x? Okay. Now, on this other side, I probably should reduce, should I? Well, this numerator, what would be x squared minus 4x minus 3? So I should check if I could factor that if I could reduce, shouldn't I? But factors of 3 do not have a difference of 4, do they?
Wait, where'd you get the 4x?
Because I have x minus 5x.
You just combine them.
I combine my terms. I have x minus 5x. When I distributed.
Okay.
Okay, so do the factors of 3 subtract to 4?
No.
No. I could add them to 4, but they don't subtract, correct? So I can't reduce there. But I probably should factor the denominator over here, shouldn't I?
Yeah.
So factors of 15 to add to 8, can I do that?
Yes, you can do that.
So negative 5 and negative 3. What do you notice? They're the same on both sides, right? Now, when I told you we multiplied both sides by this, okay, you guys ever heard cross multiplication? Okay. There technically is no cross multiplication. You're multiplying by the reciprocal on both sides, but on the left or the right, it just reduces out where it was. Okay, so I'm just going to make you aware. I'm going to say cross multiplication, but technically there is no cross multiplication, and you can only do that if there is an equal sign in between them, not an addition. I love it when people say, "Oh, I'm going to use cross multiplication," when they have a plus sign. Does that work?
No.
Okay, so actually, I'm gonna do the right thing. I'm gonna do the right thing. No, I'm not. I'm gonna go that by that and that by that because it's too much to write. So I have x minus 5 and x minus 3. What is going to happen, guys?
Seems like that's just
They're
gonna reduce.
Going to reduce, yes? Is that going to happen every single time their denominators are the same?
It'd be nice.
It is. Because I just showed you mathematically why it's going to happen every single time. If what?
The denominators are.
If the denominators are the same. So I have x squared minus 4x minus 3 and 2.
Why did it do that?
Because I multiplied both sides by x minus 5, x minus 3, because I cross multiplied, and they just reduce out. Like we did all.
And then you can solve from
Yes.
How did you go from the x squared minus 8x plus 15 to the x squared minus 4x minus 3?
I combine like terms. I have this x and this x. I had to combine. So I have x squared minus 4x minus 4.
Oh, but then what'd you do to the denominator on the other one up top?
I multiplied both sides by each other, and they're the same, so they're reduced.
I think she's at.
You guys
She's
asked
asking
me
about the
At the very
x
beginning.
squared.
What happened to
Minus
that? What happened to that?
It's right here. It's x squared minus 5, right here.
You multiplied them. I multiplied that times that.
You multiply.
Points to
Okay,
the
I have x minus 3, so I need to multiply by x minus 5. So I have 5 times x minus 5 gives me x squared minus 5x.
Yeah.
And when I take 1 times x minus 3, I get x minus 3.
Yes.
So I have x squared minus 4x minus 3.
Yeah. She's talking about how you got this one. I'm
This
confused. Where did
Yeah.
that denominator go?
It didn't. I said this 3 times already. I cross multiplied. So I multiplied, shush. I multiplied by this, which is x minus 5, x minus 3. I
Yes.
multiplied by x minus 5, x minus 3. They are the same, they reduced. Their multiplication
She factored it.
factored it.
That's what she was asking. And then you said like 40 different things. Okay.
I'm not clear. Did you not catch that we factored this?
Yes. That's why I was really confused what was happening.
Okay, because it didn't go anywhere. What do we always need to do with these things? We need to factor them, right?
Yes.
So hopefully things reduce.
Yes.
Okay, so now what?
We've got, well, you subtract 2 over.
I subtract 2, I have to set it equal to 0. When I'm solving, I'm finding x-intercepts, correct?
Yes.
And x-intercepts happen when y is 0. So that's why we have to set it equal to 0. So subtract 2. So I have x squared minus 4x minus 5 equals 0. Now what?
Negative x minus 5 and plus 1.
What are you doing?
Or we factor 5.
We're factoring. Negative 5 have a difference of 5, right?
A 4.
And both equal to 0. So I get x equals what?
X equals 5 and negative 1, 5.
Negative 1 and 5. Are they both good? Can I use them both?
Yes, because they are real numbers.
Can I? Look at the first problem.
Wait, no, you can't use 5 because it's
Why can't I use 5?
in the
Because it's in
denominator.
the denominator.
Because right there, what happens if I plug 5 in?
You get 0.
I get 0.
And you can't.
So 5 is an answer. It's called an extraneous solution. Extraneous means extra. So all you do is you leave it there because 5 is an answer you got, yes? But is it a good answer?
No.
Nope. So you just go. Because if I would have gotten 5 or 3, the whole thing, it wouldn't have worked, would it?
No, ma'am.
1 over x plus 2 plus 1 over x minus 2 equals 4 over x squared minus 1.
Do it by ourselves? No.
I was just letting you write down. You can do it by yourself if you want.
Well, that one of the different squares.
The right's a difference of squares, right? So I'll have x minus 2 and x plus 2.
Yep. And that's the same thing as the other one.
And that's the same thing as the other one, so this can be nice when I'm done, right?
Yes, ma'am.
What do I have to do with the left first?
Have to cross multiply.
No,
Nope.
first.
Add 'em. So you have to.
So common denominators.
Yeah.
So what do I have to multiply this one by?
X minus 2.
Plus, right? And what do I have to multiply this one by?
X plus 2.
X plus 2. Well, the 2's reduced in the numerator, don't they? 0?
Yeah. We just have
So, and what happens to my denominators?
denominators.
They're
When I cross multiply, they do not cancel,
They reduce.
they reduce. So I'm left with what?
X squared equals
No, you're adding
2x.
equals 4. So x equals 2. Can it be 2? Why not?
Okay, so it's not a good number.
It makes this 0 and this 0, yes?
Slow down.
So
Where'd you get 2x?
Because
an x plus x is 2x.
Oh, yeah.
So, but x can't be 2. So it is
No solution.
no solution. If the only solution you get is one that it can't be, there is no solution. So a solution to this is if I took these two graphs, solutions would be where they crossed, correct? Okay, so these two graphs, the left and the right, do they ever cross?
No, ma'am.
Good?
This is the same.
Okay, so I have 5x, it's not, over x minus 2 equals 7 plus 10 over x minus 2. Anybody got an idea?
Well, maybe once I get that right.
I mean, you probably.
would we
You put
multiply
7
x minus 2?
7 over 1, yes?
Yeah.
So if 7's over 1, what do you have to do on the right hand side?
Addition is
You have to add it, so you have to have what first? Common denominator, which is going to be what?
X minus 2.
X minus 2. So what's that mean I'm going to multiply 7 by?
X
X
minus 2.
X minus 2.
7x minus 14.
So it'd be 7x minus 14 plus 10.
So,
And then the left is what the left is, right?
So it would just be minus 4.
So what's going to happen with those denominators? They're going to do what?
Reduce.
They're going to reduce out, aren't they? It only happens if they're the what, though?
Same.
The same. If they're not the same, I'd have to FOIL them out, wouldn't I?
Yeah.
Okay, so they're going to reduce out. By the time I get done with this, you guys will probably have an answer. I get 2. You guys get 2?
yeah. And then I wrote no solution
And then you wrote no solution. Why, Kale?
because the denominator up there is x minus 2.
It's x minus 2. So is it a solution? No.
wait a second, wouldn't it be though, since it's not a negative 2?
No, the denominator is x minus 2. So if I plug 2 in there, I get 0. Okay, now all of them have had 2 of the rational expressions where it didn't work. Does it have to be 2?
No.
No, just 1. Any one, if it doesn't work, you could come out with 6 answers and it makes 3 of them don't work. You've got to check them. It just so happens when there's only, if all of them don't work, then it's no solution, right?
But if one more.
If one works, then it has at least one solution. Are you good? Okay. Don't do that. Come on.
I struck the 5 over, so struck the 7 over.
Well, if you subtract the 5 over, you'd add the 4, and you'd still get 2. I personally would do that, but some people don't like it when I do extra work just to get a positive. Do you guys know why I do extra work just to get a positive?
It's easier.
Well, it's not even easier, but what do we forget to do when we divide? We usually forget the negative hanging out on the other side, right? Come up with these like little things that help you not make mistakes.
I would have to take longer.
I I'd rather take longer the first time than have to do it twice. So it's x plus 10 over x minus 3. I thought I changed this. That is not right.
Okay.
That is not right. I was sure I changed it. It is not right. When I was typing it, I changed part of it. It should be 6 over x minus 3 is the second one. So it should be x plus 6 over x minus 3. We can do this one because it gives you a good example, but it doesn't factor in the end. So it doesn't factor in the end, so it's like no rational solution.
So
Don't do this one. The only thing that's nice about this one is you notice they don't have common denominators on the opposite sides. You see that? So you have to FOIL, but this doesn't come out with something you can factor. So. Okay,
That can't be x over 1.
yes,
Okay.
yeah, it would be x over 1.
So it'd be 6.
So what would you multiply by?
X minus 3 over 3. So it'd be
X minus 3
squared minus 3x.
plus 6. Again, and why do these numerators just go away? They really don't just go away. How? Mathematically, what happens?
They cross multiply and then they reduce.
Right, they reduce when I cross multiply, don't I? I just want to make sure we still are aware that they just don't magically walk away, do they?
Yeah.
There is a reason why they aren't there anymore.
You would subtract the 2x over.
You'd have to set it equals 0, good job. And then do what?
Factor.
Factor.
And so it'd be a negative 6 and a positive 1.
Everyone agree with him?
Yeah.
So x equals, and they're both good?
Yep.
And they're both good?
Yep.
Because it couldn't be what?
3.
3.
Could it be negative 3?
That's not right.
What do you mean?
That is so not right. I went with it. I asked if everybody agreed, and you said yes.
I
so
haven't
gotta
looked up
guess.
yet.
I didn't
Oh,
say yes. What's wrong with what he did?
He didn't factor right.
This is a positive,
Yeah. So both those have to be negatives.
so this both has to be negative. So he did the difference is -5, but I want to do what?
Negative 3 and 2. So then it doesn't work.
Okay, so it should be, it's okay.
I do all the work too. So I messed up all my homework.
Not all of it, probably. You gotta
No, I
probably
did that
half of
exact
it.
same thing.
You just rate minus 6 plus
Right,
1 no
whatever
matter
fills
what
up
the
my
number.
brain.
Oh, well, yeah, that's usually, you gotta check it.
Never.
Well, it can't be 3.
It can't be 3.
So it's no solution.
No, can it be 2?
Yeah.
No.
It can be 2, it just can't be 3. Just can't be 3.
You know, Caleb, if you wouldn't have said anything, we would have been fine and on to the next question.
Or maybe if you were writing
Oh.
it down. Yeah, I
What do
don't
you
get why
mean?
you don't take notes. Like,
I don't need those.
Hey Taylor, you remember that
I'm
pencil
gonna laugh
eraser
when
you
she
lost
gets
the
this
other
like
day?
an open notes like test
There you go.
one day and then
That's your eraser
it
for your pencil.
doesn't have anything.
I just tell you to copy like the third example in front of
Yeah.
take 2. Okay, last one I think,
Road.
pretty sure. So my denominators are the same, right?
Yeah,
It
it
looks
looks
the same. So then you got
so it cannot be
There
x
might be
minus
one
5,
more
x
for
plus 1,
It cannot be
5.
5.
different
So-
squares.
Ooh. He's saying a lot of words.
And
Hopefully in your
Yeah.
head you're doing this, okay? In your head are you doing that?
No, I didn't
not,
process that yet. You haven't got there
It's
yet.
already said equal to each other, so you can just.
Right, you can just cross multiply, they're already one thing on each side.
X equals 5.
So, no, x does not
Squared
equal 5.
X
Equals
squared
25.
equals 25.
X squared equals 25. So I can just take the square root and get plus or minus 5. But sometimes people forget, and so if you set it equal to 0, you would have the difference of squares, yes? And it would factor. And you would get what? plus or minus 5. That is why it's plus or minus. That's why. Are they both good?
No.
No.
Only
One of them
five
is,
Minus
well,
is good.
positive 5 is not.
The positive 5 is good, so x equals 5 and x
Does
cannot
not
equal negative 5. And now on this one, do I have to state both of them?
Yes.
Yes, because it physically cannot be negative 5. It's not that it just happened to work. It can't be that. I think there's one more. You guys good?
Yeah.
Oh, no, that's it.
more.
Yeet.
You just skipped like 3 pages. and that's just like-